Hello student, here is the question that magnetic field at point O, you have to calculate that point O, magnetic field at that point O. You can see that here is the current elements, elements are, first is this element, and this element is, this is the point, it is passing through that point, so its magnetic field will be 0. So here is the magnetic field, that's B1 will be equal to 0, and here is the next element which you have, this element is this one, so due to this element, let's say that's a B2. So here is this is the B2. Okay, so I'm writing that's B2, that will be equal to B2 due to mu naught into I upon 4 pi r into 4 pi r, that's r is the radius. Okay, so 4 pi r into theta. Okay, so here you can see that's a theta, that's becoming pi, that's a half ring. If you are you can write it at that's mu naught into I upon 4 pi. Radius of that loop is equal to 3r, so you will write over there that's a 3r, and that's 3r, and that's theta is equal to pi, so it will cancel out, so you will write it that's mu naught into I upon 12r. So here is the B2, and the direction will be equal to, you just move your fingers in the direction of the current, you will get the direction of thumb will give you the direction of magnetic field, so it is coming out to be inward, so it's inward in direction. Now due current magnetic field due to this element which is like that. Okay, so this element is passing through that point also, so magnetic field due to this will be equal to 0, so B3 will be equal to 0. Now magnetic field due to B4, so here is the B4 which you have, here is the B4. Okay, so here is the element which you have, it's making an angle 90 from here, so here is the element, so you will you are writing that for B4. Okay, so for B4 calculation is that's a B4. Now for B4 I am writing that's a mu naught into I upon 4 pi into, here in this formula I am just putting the value of radius, here is the radius is 2r, so I am just putting the value of the radius, that's equal to 2r into theta, that's equal to, it's making angle pi by 2, so it's equal to pi by 2. Okay, so it's cancelling out, so pi and pi will cancel out, and you will get the value over there, that's equal to 2 into 2 4 16, so mu naught into I upon 16r. Okay, so now here is the again the another element is like that, here is the new element is this element is also passing through that point, so its magnetic field will be 0, so B5 will be equal to 0. Okay, B4 equal to 0, B5 will be equal to 0. Last element which you have, it is in is like that, it is like that. Okay, so this is making angle 90 again from here, so you can write the magnetic field due to this element, that's a B6. So B6 first do the direction of B4 will be equal to, current is flowing in like that, so it will be out. Okay, so in this direction, so here B6 value will be equal to mu naught into I upon 4 pi into radius of that equal to r into theta will be equal to pi by 4, that's equal to pi by 4. Okay, so just cancel it out, you will get that's equal to and theta pi by 2, not pi by 4, that's a pi by 2, so that's equal to mu naught into I upon 8r. Okay, now just do the calculation, first find out the direction of that, so current is flowing like that, anti-clockwise direction, so direction will be outward, so here you can see that it's coming out to be outward, these two magnetic field is coming out outward, rest of the equal to 0, B4, so net magnetic field will be equal to that's B net will be equal to B1 plus B2 plus B3 plus B4 plus B5 plus B6, and you know that B1 is 0, B3 is 0, B5 is 0, so rest of the which you have here, you can calculate that mu naught into I upon 12r, and direction of that equal to inward, and plus just add it up, if I am multiplying that with 2 and 2 above and below in numerator, you will get this equal to 2 mu naught I upon 16r. Okay, it is in this direction. Now just add them, because these two are in same direction, so you will get plus 3 upon 16, 3 mu naught into I upon 16r. Okay, so it's in inward. Now you can see there that's it's equal to, so it's coming out to be, let's say that's is greater quantity and that's less quantity. So you can just make, if I'm reversing its direction, so it will become mu naught into I upon 12R, and direction will become inward, and that will be equal to 3 by 16 mu naught into I upon 16R. Okay, so 16R. Okay, now and direction will be inward, so outward. Okay, so here is the value which you have there, 16 minus 1 upon 12 into mu naught into I upon R. Okay, take the LCM, you will get 3 multiplied by 3, and here is the 4, okay, upon mu naught into I upon R. Okay, so here take the LCM, you will get the 16 multiplied by 3, so 3 into 3 it will become 9, and here 12 multiplied by 4, that's equal to 48. So here is the 4, so you will get from there, that's equal to 9 minus 4, that's equal to 5. 9 minus 4, that's equal to 5, and that's equal to 5 divided by 48 mu naught into I upon R, and direction will be out to the plane. So here is it matches with your option number 2. So option number 2 is the correct answer of this question. Okay, so it matches with your option number 2. Okay, so 5 upon 48 mu naught into I upon R. Okay, direction will be out. Okay, so here is outward direction which you have, because this direction is inward and rest of the direction is outward, and this radius is less, so this magnetic field will be more. Okay, so you can see over here, this option number 2 is the correct answer of this question. Okay, thank you.